Welcome to this course of power quality. So, we are discussing the numerical problem on UPQC. So, coming to ninth numerical problem, a single phase UPQC consisting of D STATCOM and DVR using 2 VSC with common DC bus capacitor is to be designed for a load compensation of 230 volt, 50 hertz, 25 ampere lagging power factor at a right hand UPQC S, and there is a voltage sag of minus 20% in supply voltage with the base value of 230 volt. Calculate the voltage rating of DVR, current rating of DVR, VA rating of DVR, voltage rating of D STATCOM, current rating of D STATCOM, VA rating of D STATCOM to provide the reactive power compensation for unity power factor at PCC voltage with the constant voltage regulator across the load. Consider the same power angle for both reactive power sharing in both VSC in a steady state condition for unity power factor at AC means without voltage sag condition. So, this is typically the right hand. So, we have a D STATCOM on right hand side and we have a DVR on left hand side. This is typically the phasor diagram for the condition which are given, that we are putting a this typically the angle same in both conditions without sag and with sag, and these are the voltage waveform after making the model of this like. So, coming to numerical part of this, given that voltage 230 volt 50 hertz at a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor, there is a voltage sag of minus 20% in the supply system, base value of 230 volt. So, under steady state condition for unity power factor of AC means without voltage sag, the active power of load is typically of your VIPF. So, it comes 4600 watt, and reactive power of the load is like your 230 25 into 0.6 3450 VR, and the supply current is typically power divided by the voltage 20 ampere, and power factor angle is 36.86. So, in the right hand UPQCS, the each VSC have a reactive power rating equal to half of the reactive power of load, which is equal to your reactive power 3450 by 2. So, it becomes like 1725.25 VR, and from the following relation of reactive power of DVR, the power angle computed is typically your from the VR, that comes delta equal to 22.02 degree. So, PDVR from this angle calculation comes 339.69, and SDVR is a QDVR plus PDVR, so it comes 1758.12 angle, and IDVR equal to IS, that is 20 ampere, and voltage DVR is typically SDVR divided by SV calculated. So, IDVR, so it is a comes 87.90, and this minus sign denotes the DVR absorbing this active power which is fed to DC bus, and therefore, active power of D STATCOM is equal to PD STATCOM PDR equal to 339.69, and the voltage rating of D STATCOM equal to the load voltage, that is 230 volt, and current rating of D STATCOM can be calculated from angle beta equal to 5 minus delta. So, it comes like 14.85. So, D STATCOM current can be calculated higher in terms of load current and power factor angle and beta angle, it comes 7.64 ampere. So, phase angle between the D STATCOM voltage and current can be calculated 339 P equal to 339.69 watt, and from this phi DST will be your phase angle will be 79.02 degree, and Q DST will be 1725 VR, and S DST will be 1758.12, and voltage sag compensation of right hand PQC will be equal to the VS dash equal to typically the sag, it is a point typically 8. So, supply current after the sag compensation is your typically active power 4600 divided by 184 with, because it is a unity power factor, it comes like a 25 ampere, and in right hand UPQC the same power angle Q equal to 22.02 degree, and from the above relation the power can be calculated of Q DVR equal to from this relation. So, putting the value it comes to 155.85 VR, the angle power angle is of 22.22. So, we can calculate the power DVR equal to from this relation. So, it comes 730.55 watt. The voltage rating of DVR is equal to typically from the load voltage and from these factors. So, it comes 91.05 volt, and current rating of DVR from this voltage sag compensation will be your power divided by your voltage. So, it comes 25 ampere, and VA rating of DVR is your voltage multiplied current. So, it comes to 276.27 watt VA, and active power D STATCOM is equal to 730.55 watt, and the voltage rating of D STATCOM equal to the typically is a 230 volt, and the current rating of DStatCom is computed equal to beta equal to 5 minus delta, that is 14.85. So, DStatCom current rating comes from this relation, it comes typically putting a value 6.46 ampere. So, phase angle between DStatCom voltage and current can be calculated from the active power and from reactive power, that comes from active power phi DST equal to 119.5 degree, and from which we can calculate now Q DST 1293.88 from putting this relation here, and V rating of VSC of DStatCom is equal to VST DST. So, 230 into 6.46, so it comes 1485.88 VA, and voltage VA rating of the UPQC during voltage sag conversion is your UPQC equal to SDST plus SDVR. So, it is virtually 1485.88 plus 227.6.227. So, it comes 3762.15 VA. So, hence considering the overall rating both normal and under voltage sag, the rating of both compensator are VDVR equal to 91.05, IDVR equal to 25 ampere, and SDVR, VDVR, IDVR. So, putting the value of voltage and current, it comes to 276 VA, and VDStatCom is 30 volt and current is 7.6. So, SDST will be your 1757.22, and overall VA rating of the UPQCS will be your DStatCom rating plus DVR rating, that is 1757.2 plus 2276.27. So, it comes 4033.47 VA. Coming to the 10th numerical problem, a single phase UPQC consisting of your DStatCom and DVR using two VSC with common DC capacitor is designed for a load compensation of 230 volt 50 Hz 25 ampere 0.8 lagging power factor as a left hand UPQCS, and there is a voltage sag of minus 20% in the supply system with a base value of 230 volt. Calculate the voltage rating of DVR, the current rating of DVR, VA rating of DVR, voltage rating of DStatCom, current rating of DStatCom, and VA rating of DStatCom. So, total VA rating of UPQCS to provide reactive power compensation for unity power factor at PCC with constant voltage regulator 230 volt 50 Hz across the load. Consider the same power angle for equal reactive power sharing in both VSC in steady state condition at for unity power factor AC means without voltage sag condition. So, this is typically we can call it is a left hand UPQC. So, this is the circuit of left hand UPQC where DVR is on right side. This is the phase diagram for a given condition, and these are the typical waveform. So, coming to the numerical portion, given that the V equal to 30 volt 50 Hz, load of 230 volt 50 Hz to 25 ampere point lagging power factor load, there is a voltage sag of 20% in the supply system with the base voltage of 230 volt. Both VSC have a same rating. So, it means that after the voltage supply reduces to 230 with the sag of 20% 184 and X is 0.2, that is the typically the level of sag compensation. So, under steady state condition for unity power factor AC means without voltage sag compensation is the power active power VLIL. So, that is virtually putting a value, it comes 4600 watt, and the reactive power of the load comes from this 3450 VAR, and supply current from power and voltage because power factor unity on supply side after compensation. So, it comes 20 ampere, and in the left hand UPQC each VSC have a reactive power rating equal to half of the reactive power of the load, which is equal to your QL upon by 2. So, it comes 1725 VAR. From the following relation of the reactive power of DStatCom, the power angle can be computed. So, reactive power of DStatCom is Q DST equal to VL sin beta. So, it comes 1.1725, from where beta can be calculated 17246 degree, and from which once you know already phi power factor angle and beta angle there. So, delta can be calculated. So, it comes 19.41 degree. So, active power DStatCom from this now can be calculated from this relation. It comes 85.15 watt, and current rating of DStatCom can be calculated from V rating of DStatCom divided by voltage rating. So, this is P square under Q square. So, by divided, so it comes 8.43 ampere, and typically the angle of DStatCom becomes 117.22 from this relation from power and V rating, and the DStatCom V rating comes like your current multiplied the voltage, it comes 1938.9 VA, and minus sign denotes that the DStatCom observing this active power which fed to the DC bus. Therefore, active power of your DVR is at PDST equal to 885.15 watt, and current rating of DVR of UV is equal to the AC load current of 25 ampere. The voltage rating of DVR of UPQC is computed as your V rating of dVr divided by current. So, this the V rating divided by current is 77.56 volt, and Q dVr will be equal to, from this relation comes like a 1725 VR with the angle of 62.79, and P from which you can calculate the power is same. So, 885.15, and SDVR will be under root P square Q square. So, it becomes 1938.95, and voltage sag compensation by left hand QC. After the voltage sag, it means after the voltage sag the supply voltage reduces by 20%. So, it becomes like 184 with x equal to 0.2, and K is calculated for the depth is 1 upon 0.8 1.25, and A is equal to 1 upon K 0.8. So, supply current after the sag composition is your I s equal to P L upon V. So, it comes 25 ampere, and V dStatCom again comes because it is left hand, it is a 184. So, under the voltage sag condition, the same power angle of 91.41 from the following relation of reactive power dStatCom can be computed. So, delta equal to 5. So, that comes 19.41, and from this Q DST can be calculated from this angle. So, it comes 1380. So, you can calculate the delta as well as beta comes 17.46 like, and power for dStatCom comes from this relation equal to 2.11.94, and your phi DST becomes from power divided by VA. So, that is cos inverse of this, so 81.31 degree, and the current rating of dStatCom can be computed from power V, and typically this relation from active power to 7.59 ampere, and V rating of dStatCom computed from V DST I DST. So, it comes like typically 1396.37 volt ampere. So, rating of the dVr is computed from the common relation of dStatCom and dVr, and active power of dVr is your dStatCom equal to dVr equal to 211.94 watt, and current rating of dVr of UPQC is equal to the AC load current of 25 ampere, and the voltage rating of dVr is computed as typically the remaining reactive power of the load not supplied by dStatCom had to be supplied by dVr, which is computed here typically from this 3450, that is total load reactive power, and this is by dStatCom. So, the dVr have to supply the 2075 VR, and you can find out the dVr VA rating under root P square Q square. So, it comes 2080 VA, and V dVr from this from S, and current can be calculated, it comes 83.23 volt, and the V rating of dVr comes from typically P square plus Q square under root. So, it is 2080.64, and V rating of UPQC will be the during the sag will be your dStatCom VA rating, and dVr voltage rating, it comes totally 3477.01 VA. Hence, considering overall rating both under this, the rating of both capacitors are V dVr equal to 83.23 and I dVr 25 ampere, and S dVr equal to, giving the value, it comes to 080.75 VA, and voltage of dStatCom, current of dStatCom, so it comes like a typically 1938.9 VA, and the overall VA rating of UPQC comes sum of the both. So, it is 4019.55 VA. However, in case of the same inverter for both the inverter same, so power converter can be of the same rating of SDST equal to SVR 2080.75, hence overall rating of the is thus equal to the sum of both. So, it becomes 4161.5. Coming to the numerical example 11, a single phase UPQC consisting of dStatCom dVr in 2 VSC with common disk capacitor is to be designed for a load compensation of 230 volt 50 hertz as a left hand UPQC. So, there is a voltage sag swell of 20% in the supply system with the base value of 230 volt. Calculate the voltage rating of dVr of UPQC, current rating of UPQC, V rating of dVr, voltage rating of the dStatCom, current rating of dStatCom, and V rating of dStatCom and V rating of UPQC to provide the reactive power compensation for unity power factor at PCC and constant voltage regulator of 230/50 Hz across the load. Consider the same power angle for equal reactive power sharing in both VSC in steady state condition for unity power factor AC without voltage swell condition like. So, that is typically left hand UPQC because dStatCom on left side and we are on right side, and this is the phase diagram corresponding to this voltage swell typically condition, and this is typically the waveform corresponding to that. So, coming to the numerical portion, given that 230 volt 50 hertz, a load of 30 volt 50 hertz, 25 ampere 0.8 lagging power factor, there is a voltage swell of 20% in the supply system with the base value of 230 volt. So, under coming to steady state condition without voltage swell, the active power of load is VLIL into O. So, putting the value, it comes 4600 watt, and reactive power of the load will be like corresponding to VLIL under root 1 minus power factor is square. So, putting the value, it comes 3450 VR, and supply current equal to I s equal to P L upon V s, that is 4600 power 230, that is 20 ampere. In the left hand UPVC, each VSC have a reactive power rating equal to half of the reactive, which is equal to the QL upon 2 equal to 3450 divided by 2, it comes like a 1725 VAR, and from the following relation of UP, the phase angle can be calculated. So, reactive power of this equal to the, from this, so we can calculate the value of beta equal to 17.46, phi equal to 19.41. The active power of G STATCOM equal to, from this calculation we get the 885.15 watt. So, current rating of the G STATCOM from this relation, by putting the value, it comes like 8.43 ampere, and the angle of D STATCOM virtually comes 117.22 degree, and the VA rating of D STATCOM from this relation 1938.9 VA, and minus sign denotes that the D STATCOM observing this active power which is fed by DC. Therefore, active power of DVR is same as the D STATCOM, that is 885.15, and current rating of DVR is equal to 25 ampere, and the voltage rating of DVR is computed from here. It comes like a VA rating divided by current, so it is a 77.56, and the Q, reactive power rating of DVR is 1725. So, phi DVR equal to 6.79 and P DVR from 885. So, as DVR comes from this, so it comes 1938, which is same as the D STATCOM rating. So, coming to voltage sag compensation by now, typically of left hand UPVC, it means after voltage sag supply voltage increases to like 230 into 1.2. So, it is 276 volt with this, and you can calculate the K 0, that comes typically 0.833, and then it comes 1.2. So, supply current after the swell compensation is typically 4600 divided by 276. So, it is a 16.67 on supply side, and since the D STATCOM is connected AC means, so the voltage of D STATCOM is same as the AC voltage. So, that is typically 276 volt. Under the voltage swell condition, the same power angle of 19.41 from formulation of the reactive power of D STATCOM can be computed. So, Q DST equal to D STATCOM rating, from this relation it comes typically like a 2070, and from which beta is calculated 17.46 and delta 30 typically 19.41, and the power of D STATCOM come from this relation 2.09 watt, and SDST under it becomes a P DST plus Q DST under root of that, putting a value it comes 2866.13 VA. So, coming to current rating of the VA, so we know VA rating divided by voltage, so it comes 10.384, and the angle of D STATCOM comes from this relation 133.75, and VA rating of D STATCOM is your DST, it comes like typically 2866.13, and the rating of DVR is computed from common relation of D STATCOM DVR. So, it is a power is active power both, because whatever power DVR taking D STATCOM have to give, so it comes 1982.08, and the current rating of DVR for equal to AC load it is a 25 ampere, and the voltage rating of DVR of UK is computed as the remaining reactive power not supplied by D STATCOM supply from DVR. So, Q DVR equal to the difference of it comes 1379.2, and P D STATCOM Q STATCOM same, that is 1982.09. So, S DVR will be equal to square root of both 2415 VA, and V DVR from S DVR by A DVR it comes like 96.06 96.6 volt. So, V rating of the DVR comes like a VAR of the load minus the D STATCOM reactive power, that comes 1379 VR, and P DVR DVR both are same and 1882.09, and S DVR is now from this relation comes 2415, and V rating of UCAS for voltage swell condition comes sum of the both VA. So, adding this it comes 5281.18, hence considering overall rating both normal and the rating of both compensators typically are. So, V DVR 96.6, I DVR 25 ampere, so S DVR will be 2415, and V DST is 276 and DST is 10.36, putting the value it comes 2686.13. So, total rating is the sum of both VA rating, it comes 5281.18 VA. Coming to numerical problems 12, a 3-phase supply with the AC line voltage of 415 RMS 50 hertz is fitting the critical load of 50 kVA 415 volt 50 hertz at 0.8 lagging power factor. A voltage sag of 10% occurs in the supply voltage of PCC. Design a 3-phase UPVC consisting of D statcom and DVR with the common DC bus capacitor in this system to compensate the power factor of the load to unity and at AC mains and mitigation of the voltage sag to avoid the interruption of the load. So, if two 3-phase VSC are used as a right hand UPQC, calculate the voltage rating of the DVR, current rating of the DVR, V rating of the DVR, voltage rating of the D statcom, current rating of D statcom and V rating of D statcom and V rating of total UPQC Q to provide the reactive power compensation for unity power factor AC main with constant voltage of 415 volt 50 Hz in 3 phase. So, this is you can call it the right hand UPQC. So, D statcom on right side, DVR on left side, and this is typical because it is a UPQC. So, we have to add per phase, this is a per phase phasor diagram. So, we have to add the voltage to bring this both voltage equal. I mean, so that both voltage are equal, and this is typically you can call it source voltage. I mean, because of sag, but grid current and the typically the load voltage, load current and the DVR voltage to be injected. So, given the condition that supply voltage 415 volt 50 Hz and load of 415 50 Hz 50 kVA lagging power factor load. So, there is a voltage sag of 10% supply system with a 415 volt and operation of UPQC under normal condition. So, under normal condition the DVR of QC injects 0 voltage because as the same thing, however, the D statcom inject the current in the quadrature to the load voltage for compensation of reactive power. So, you can calculate the per phase voltage, then the typical here the inactive power of the load, and from this you can calculate the reactive power, and this reactive power have to supply virtually from typically from. So, you can calculate the supply current and then you can calculate the typically a D statcom current from reactive power, and so D statcom rating is corresponding to load reactive power, that is 30 kVAR. Now, coming to the case of voltage sag compensation by right hand right hand UPQC. So, voltage rating of the DVR of UPQC is a 10% sag. So, it becomes with the base voltage of 239. So, after the sag you can call it line voltage becomes 373.5 volt and the phase voltage becomes 215.64 in place of your 239.59, and phase load current from active power, and from this relation you can find out under normal typically of 69.59 this much current, and the supply current for the voltage sag compensation certainly with the active power divided by your voltage and 3. So, it becomes 61.81 and the voltage rating of the DVR from this relation because it is a Q. So, V square minus VSC square V DVR. So, putting the value it becomes 104.44 volt, and the current rating of DVR of UPQC must be the same as the supply current after the compensation. So, IDVR equal to fundamental active power of the load current, that is from this. So, we can calculate 61.83, and thus the V rating of the series element will be your VR. So, we had no injected voltage current multiplied with the 343 phase. So, it becomes typically 373 VR and power is 0. So, SDVR because it is a UPQC Q. So, the VR rating becomes like a simply 19.373 kVA, and voltage rating of the D statcom is equal to the same as load voltage rating because it is connected across the load. The voltage compensated there. So, 239.59, and current rating of D statcom we computed as the D statcom is correct to power factor to unity, and the required reactive power by the D statcom is now lower than the reactive power of the angle between the supply voltage and current is reduced to beta equal to phi minus delta, where cos phi is the load power factor and delta is the angle between the load voltage and PCC voltage after compensation, and this angle computed as your VDVR from this. So, it comes delta equal to 25.83 and the power where the power factor angle 30 is corresponding by cos inverse 0.8, that is 36.86. So, then we can find out the from this relation the D statcom current rating on per phase basis. So, it comes like a 14.796 ampere, and V rating of D statcom from this relation comes to be your 10.63 kVA, and power active power is 0 because DVR is not asking any power because it is a UPQC Q, and the V rating of the D statcom is same as the is Q rating. So, it is a like you can call it 10.63 kVA, and voltage rating of UPQC during the voltage sag condition. So, sum of the both it comes 10,630 plus 19,373. So, it becomes your 30 kVA, and hence considering the whole rating of both under this. So, we have voltage rating of D statcom 239.6, current rating 41.73. So, D statcom rating comes 30 kVA and DVR voltage rating is comes 104.44 and current rating 61. So, VR rating comes to 19 point, and total rating is the sum of both, it comes like 49.37 kVA. Coming to the numerical 13, the 3 phase supply with the AC voltage of 415 volt RMS at a 50 hertz is feeding critical linear load of 50 kVA for 15 volt at 0.8 lagging power factor. A voltage swell of 10% occurs in the supply. Design a 3-phase UPQC consisting of DVR and D-STATCOM. The common DC capacitor in this system to compensate the power factor of load to unity at the AC mains, mitigation of voltage swell to avoid the interruption of the load. And if the 3-phase PSC are used as a right hand UPQC P, okay, calculate the voltage rating of the DVR, current rating of the DVR, voltage rating of DVR, current voltage rating of D-STATCOM, current rating of D-STATCOM, VA rating of D-STATCOM, and total VA rating of the UPQC, interfacing inductance, DC bus capacitance, DC bus voltage, transfer ratio of injection transformer. Consider the switching frequency of 20 kilowatts. DC voltage have to be controlled within 8% of the range value, and ripple current in the interfacing inductor is 5%. So, this is again you can call it right hand UPQC, means shunt is connected across the load and series is in series with the line, and these are typically phasor diagram corresponding to this typically the swell compensation. These are the supply voltage, supply current, load voltage and load current, and the DVR voltage to be injected. So, coming to the solution, given that the supply voltage 415 volt at 50 hertz and load voltage 50 hertz 415 50 hertz 50 kVA 0.8 lagging power factor, there is a voltage swell of 10% and supply voltage 15. So, the phase voltage comes like typically 415 by root 3 239.59, and typically the phase load current is your active power divided by your 3 times voltage. So, it is 69.56, and active power comes typically of your from this relation 40 kilowatt, and the current of grid is typically under normal condition comes 50.64 ampere. The voltage swell compensation by right hand UPQC. So, after voltage swell the supply voltage increases to 10% voltage swell, so it comes 456.54, or phase voltage is typically 263.56 in place of 239.39. So, the voltage rating of the DVR of UPQC is computed as for UPQC P, the injected voltage in phase with the source voltage, and the value of injected voltage is the algebraic sum of the difference of the two. So, you can find out D-STATCOM DVR voltage equal to directly 23.96 volt, and the current rating of DVR of UPQC must be the same as the current rating of the swell condition. So, from this we can find out the current form typically on the grid side. So, it is 50.5, and so for the voltage swell compensation the V rating of series element of UPQC is P DVR equal to 3 VDVR I DVR. So, it becomes like a typically your 3.6364 kilowatt, and Q equal to 0, and SDVR equal to P under Q. So, it becomes 36.4 VA, and the voltage rating of the D-STATCOM same as equal to the AC load voltage because it is connected across the load. So, it comes 239.59, and current rating of D-STATCOM as the UPQC P is the same, V rating is the same reactive power of the load, and active power is the same as your DVR 36.4, and SDVR under root of QP square plus Q square. So, it comes 30.22 kVA, and from this we can calculate the current rating of typically of D-STATCOM, it comes 42.04 ampere. So, V rating of D-STATCOM comes SD under root Q square plus Q square. So, it is a 30.22 kVA, and the V rating of the UPQC during voltage swell comes sum of both. So, it comes 33.856 kVA considering the overall rating of both typically under normal and swell condition. So, it comes D-STATCOM voltage rating of 239 with a current rating of 42. So, SVA rating comes 30.22 kVA, and DVR current voltage rating to 23.96, current rating 50.64. So, VA rating comes 39.99 kVA, and overall rating is the sum of both, it comes 34.22 kVA. So, turns ratio of the injection transformer is now corresponding to DC bus capacitor of 750 volt for 15, and D-STATCOM can obtain 415 across the line of this. However, the DVR requires this much. So, therefore, the turns ratio of this can be calculated from here around 10, and the DC bus capacitor decided according to this value. So, it comes 752, we can select 750, the interfacing inductance required for which is this. So, we can calculate D-STATCOM rating from this relation. So, it comes 1.92, and DVR current rating from this relation comes to 116 millihenry, and the DC bus capacitance of this from this dynamics of this which you calculated for other compensator also, it comes like a 7018.28 microfarad. So, coming to the numerical number 14, a 3-phase supply with the AC mains voltage of 440 volt 50 hertz has a voltage sag of 20% due to rural feeder and nearby factory. Hospital needs a 3-phase 415 volt 100 kVA 0.8 lagging power factor linear load in critical equipment. If the right hand UPQC considering the DStatCom DVR using U2PQC with common capacitor is used as a UPQC, then the calculate the rating of the shunt and series component UPQC to provide the rated voltage across the load and to realize the unity power factor AC mains. If an injecting transformer is used to inject the voltage, here calculate the turns ratio of the injecting transformer interfacing inductors and the value of DC link. Consider the switching frequency of 10 kilohertz and DC link voltage have to control within 8% of range and reveal 10%. Consider the same rating of both beacons. So, it is we have a again right hand UPQC and injection transformer with DVR is on the left side, and this is the typical phasor diagram corresponding to that. These are the typical waveform 4. So, coming to the numerical portion, given that the voltage is 440 volt 50 hertz, a load of 415 100 kVA 0.8 lagging power factor. There is a voltage sag of 20% due to rural feeder, and it means the voltage supply reduces to your 414 to 0.8. So, it becomes 352 and phase voltage become 203. However, load voltage is your 239.59. So, your phase current becomes from the typically your 100 kVA divided by 12, it becomes 139.12 ampere, and power active power becomes like a 100 kVA into 0.8 80 kilowatt, and supply current after the some compensation from this kilowatt divided by the voltage into, so it becomes 139.22. So, under steady state condition for unity power factor AC means the voltage compensation, the active power of the load is 80 kilowatt and the reactive power is typically 60 kVAr, and voltage rise for the compensation for right hand UPQC. So, even under nominal grid condition the voltage is 254 and the per unit extra voltage is typically, you can call it under nominal condition 6% higher, and you can calculate all the constant. So, you can calculate current on this on supply side. So, it comes like from this voltage, it comes 104.99 ampere. In the right hand, each UPQC has a reactive power rating of half of the this equal to, so it is a 60 by 230 kVAr. So, under normal voltage right condition, from the following relation we can find out the Q dVR. So, from this we can calculate the delta equal to 23.43 and P dVR. From this relation we get 107.66 110.77 kilowatt. So, voltage rating of the DVR from this relation we can calculate. So, it comes 101.12 and current rating of DVR from this relation from power and voltage we can calculate the 104.99, and V rating of the DVR comes from typically voltage and current. So, it comes 31.87 kVA, and active power of DStatCom virtually the same active power of the DVR, that is 10.75 kilowatt, and voltage rating of DStatCom is same as the load to 39.6. So, current rating of DStatCom is computed, that is corresponding to this angle beta equal to 5 minus. So, it comes 13.45. Therefore, DStatCom current rating from this relation keeping the value, it comes 44.34, and phase angle between the DStatCom voltage and current, from typically the power here is, so from active power we can calculate the angle of the DStatCom 70.29 and the reactive power corresponding to 30 kVA, and voltage rating of DStatCom is typically of 239. So, we can find out VA rating voltage and current. So, that comes 31.87 kVA, and VA rating of the UPQC, the sum of the both DStatCom and DVR. So, it comes 63.75 kVA, and voltage sag compensation by return after the voltage sag. So, it reduces to typically like your 80% 352 volt, and phase voltage becomes 2 by root 3 203.22, and phase load, however, load voltage is supposed to be regulated to 39.59. It means after the voltage supply reduces to with this. So, you have a sag of 15.2 and corresponding to this. So, you can find out the typically supply current corresponding to this voltage. So, it comes 139.212, and in the right hand UPQC each VSC have a reactive power rating equal to half of the reactive power. So, that is 60 by 230 kVAr, and the voltage sag the following relation of reactive power angle to be computed. So, it comes delta equal to 0.85 from this relation, and PdVR from keeping the value it comes 9.42 kilowatt, and voltage rating of DVR comes from this relation 79.88. I am inputting the value. So, current rating of DVR comes from this active power on the grid side. So, it comes like a 131.21. So, VA rating of the DVR comes 3 times voltage current, it comes 31.44 kVA. the active power dStatCom equal to same as DVR, because DVR taking same DVR, so it is 9.42 kilowatt, and current the voltage rating of the dStatCom UV is equal to the AC load voltage, that is 239.2, since it is connected across the load, and current rating of dStatCom UC computed from the angle between the supply voltage, that is beta equal to 5. So, 18.32, so current from this relation can be is calculated 43.74, and phase angle between dStatCom voltage and current is calculated from the active power. So, it comes 107.47, and the reactive power from putting this value it comes 30 kVA, and VA rating of dStatCom is 3 times voltage current. So, it comes 31.44 kVA. So, VA rating of UPQC is sum of the both kVA. So, it comes typically double of this. So, it is 62.88 VA kVA. Hence, considering the overall both normal this rating, so dStatCom voltage rating, current rating, and the total rating is a 31.87 kVA, and the DVR voltage and current, and it comes the typically the kVA rating of dStatCom 39.80 kVA. So, total V rating of considering the both share equally, so sum of both, so it comes typically 71.67 VA, and total V rating considering the inventory same, so it is a 39.8. So, overall V rating comes sum of both, it is a 79.61 kVA. So, turns ratio of the injection transformer of this, I mean from corresponding to the voltage 415, we have to generate to 100 1 this. So, turns ratio comes around 2, and the DC link voltage from the basic relation can be calculated, it comes 750 volt, and interfacing inductance required for typically from this relation putting the value it comes 1.86, interfacing inductance for VSC of DVR it comes 1.238, and DC bus capacitance for dynamics of energy storage it comes 722 7.85. So, with this we will like to summarize that UPQC offers best retrofit solution for both current and voltage based power quality problem. It is able to compensate voltage sags well, especially the voltage based compensation as well as current based compensation, and we have seen the variety of the numerical problems. The rating differs with the configuration of the placing of your, whether you are putting dStatCom on the load side or on the grid side, but preferred configuration is certainly putting the dStatCom on load side. I mean that we have concluded, and it is able to compensate, and with we have to use the right control with the typically, I mean with this with the maybe with the UPQC S like I mean or so. So, it is capable of supplying the regulated voltage across the load and maintaining the unity power factor on the grid side, in spite the voltage may be unbalanced or the typically current may be also unbalanced. Well, with this now we would like to summarize this lecture on unified power quality compensators. The UPQC offers the best retrofit solution for current and voltage based quality problem. We have discussed the configuration of UPQC. The best configuration among the various configuration is that we put the dStatCom or shunt compensator on the load side, that is on right side, and the DVR on left side, and as far as the typically the control part is typically from UPQC S, that is corresponding to control with the angle control, I mean like, and with typically I mean it can provide you very clean voltage across the load with the, you can call it balance and unity power factor current on the supply side like. So, thank you very much.